All right, good afternoon. I hope everybody is doing well today. Of course, you wrote across the top of your paper, Lesson 8-1, Part 2. Make sure you wrote Part 2. This is a continuation lesson, and it will be wrapped together with Lesson 1. You're going to get the same homework assignment at the end of this lesson, and it will all be wrapped together as one grade. Today's warm-up is a quicker warm-up. It's a quick review of what we did last time, so let's see how we did. We're going to do this by survey. So, number 1, give me a thumbs up if that is a quadratic function. Thumbs up if it's quadratic. If you don't put your thumb up, you're saying it's not quadratic. All right. No, this is not quadratic because the second differences are not constant. We'll get to why in a moment. Number 2. We're going to do by survey as well. Give me a thumbs up if that is quadratic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 students think this is quadratic. Put your thumbs down. It is quadratic. Could someone explain why? What makes it quadratic? Danielle and then Juliana. Okay. What did she say? That's actually not what she said, but you kind of clarified it, and that was really good. The highest exponent is 2. That's what makes it quadratic. Okay? Good. So, number 2 was more visual. Number 1 required a little bit of work, and there was a few different approaches you could have taken. What did you do for number 1 to figure it out? Start with Cameron, then Selena, then Raquel. What'd you do?
I made a chart.
You made a chart, okay. What did it look like?
On the left side, it had like -3, -2, -1, and 0.
Okay, what are those all called?
X.
Okay. So did your table look something like this?
Yeah.
Okay. Very good. And then from there, you found the differences?
Yeah.
And then you were able to tell. Okay, Selena, what did you do? You did the same thing. Raquel, what did you do? Did anyone do anything different? I saw at least a couple of people who were about to try something different. Today, what did you do?
I left it like that and then I just did. I left it how like the order grade up there and then we did that.
So you did the differences, but you left it just like this, so you kind of looked here and here and here, and then you looked here and here and there. Very good. Outstanding. Anyone do anything still different? Good. Does anyone have any concerns, any issues, any observations that you've made? Good. Well, as I've said, today is going to continue from last time. There was a lot of different ideas wrapped up into this introductory lesson for Chapter 8. And so there was just too much to do in one day. So one idea that we did not talk about yet was different pieces of the actual graph, the parabola that you learned about last time. When we have a parabola, there's 2 different ways it could go. It could either open up or it could open down. Depending on which way it opens, we get a point from it. We get a vertex. The vertex is either the highest point or the lowest point, depending on which way it opens. So, if we have, So let's start here. So I know words are up here, but let's start here with the graph. This parabola opens up. Because it and this is the graph of this quadratic. Because it opens up, we have a point at the bottom. That is the lowest point of the graph. There is no part of the graph that is underneath that. that point is called the vertex, and the coordinates can be found just by looking at the grid. So this is -3, 0. But we also get the fact that this is the minimum. Minimum means lowest point. So we get the minimum of 0. Because when we talk about low and high, we're talking about the y-axis. How far up or how far down? How high you are, how low you are. So this point is right here on the y-axis. And so that's a minimum of 0. If we look at this graph by comparison, this is the graph of this quadratic function. We get this point, which again is called the vertex, and its coordinates are 3, 5. But because it's opening down, that point is the highest point. The graph does not go up above, anywhere up here. That's the highest point, and so that's referred to as a maximum. But again, we're talking about how high something goes, and height has to do with the y-axis, up and down. And so that's why we get the 5. So the minimum or the maximum will always be the y-coordinate of the vertex. And that's why you see the same number twice. It's the y-coordinate of the vertex because we're talking about up and down. Any questions about that? Well, left and right has to do with x's. And that's not what we're talking about right now. Right now we're talking about up and down. Okay, so right now we're only going to be talking about the y-axis for most of today. Okay, it was a good question. Let me elaborate on the y-axis a little bit. You see these arrows here? That arrow, and that arrow, and that arrow. It's a little hard to imagine. You have to use your imagination pretty creatively, but those arrows mean that it's going to keep going and going and going and going and going. And it's going to keep going and going forever. Which means that if we followed this from right here and just kept going up and up and up, we would be going further to the left and further to the left and further to the left, and we would just keep going up and up and further to the left. And eventually we would just go all the way to the left, and we would never stop. Same thing would happen going to the right. This would keep going up and up and up, and it would keep going further and further to the right. That way. And so the x values, we keep using all of them. In fact, if you notice what I've highlighted the whole x-axis because we use all of it. Same thing will happen even if it's going down. This will keep going in this direction. This will keep going in that direction, which means the x-axis will keep being used. So we don't have to worry as much about what's happening on the x-axis as we do on the y-axis. Any questions about that? Any concerns? Good, so let's try and put some of this into practice. And so what I would like you to do is you have graph paper, you have a ruler at your desk. I would like you to recreate graph A. So we have something to refer to, and I don't want you to worry about part B yet. And to make a parabola, you need 5 points, but you can actually do it to some degree with 3. So you need to figure out where that is. That's crossing at 6.5, and it crosses there at -6, 6.5. So you can do a good job of approximating this graph. And once you have the graph, we're going to talk about the vertex and the minimum or maximum. All right, so you should have your own copy of this. So now let's talk about what we're asked to do. Identify the vertex, and then give the minimum or maximum of the function. So let's start with the vertex. We need the coordinates of that point. What are the coordinates of that point? You should know it because you needed to know it to draw the graph. So what are the coordinates? Okay, we'll start with Kiara and Kayla. What'd you get?
3, 2.
Okay.
Oh, wait,
You want to modify yours? -3? Okay, because I was going to say 3, 2 is going to be over here. -3, 2. Yep, absolutely. So -3, 2 is the vertex. Now, I would like to know if we are going to have a minimum or a maximum, and then I would like to know what that value will be. So just tell me, is there going to be a minimum or a maximum? Jamel? You sure? Yeah, because the vertex is at the bottom, that's the minimum. Okay, so we're going to have a minimum. We can abbreviate that with MIN, that's fine. But what is the minimum going to be? Raquel, and then Daniel? What do you think? Yeah, the minimum is going to be 2 because 2 is the y-coordinate of the vertex, and 2 is the lowest point on the graph. That's why it's called the minimum. Another way to look at this is this. If I were to draw a line across the minimum value, look at where it crosses the y-axis right there. It crosses at 2. So the minimum value is 2. This is a 2 right here. Right at that point. Okay? And that's where we get the minimum of 2. Any questions about identifying a vertex, identifying a minimum? Also notice that the graph goes from this point up. So this is what we're using. We're using that part of the graph. We don't need any of this down here to draw this graph. We need only this part up here. That's going to be something we're going to need later on. Any questions? Good, so let's look at another one. Let's go ahead and take a moment to sketch out this graph. And again, you need at least 3 points to be able to approximate a curve. So you've got the vertex, you're going to have to read and look at where that is. And then it crosses at -3 on the y-axis, and it looks like it crosses at 4, -3 right there. And then you should be able to approximate the curve. So take a moment to go ahead and sketch that out. Take another 30 seconds. All right, so you've had a chance to construct this graph. So now we want to, again, identify the vertex and then identify the maximum or the minimum. So what is the vertex? I got 2, 3 people who can identify it, 4, 5, 6 people who can identify it. Cameron and then Sam. Cameron, what's the vertex?
2, 5.
Sam, do you agree with that? Yep. It is 2, 5. And then Sam, are we going to have a minimum or a maximum? We're going to have a maximum. So you can use MAX to abbreviate. What will that maximum value be? What will it be? Randy? It will be 5. Very good. Because it's the y-coordinate of the vertex, but it's also just the highest point on the y-axis that the graph goes. Any questions about that? Any questions about identifying a vertex or identifying minimum and maximum? Yes, and then yes.
When you're getting the maximum, you like only look at the y.
Yep, because we're talking about up and down. And the y-axis is what represents moving up and down. Okay? So we're just talking about how high are we going or how low are we going. And that's why we look at y. Okay? Good. Selena? Same question? Good. Does it make sense? Okay. I don't expect you to be an expert yet. All right? Checkpoint number 1. You do not have to copy anything. Just write checkpoint number 1, A and B, and find me what I would like. I would like the vertex, and I would like the minimum or maximum. Make sure you write minimum or maximum, and then its value. So you got 2 minutes on the clock. If you finish before time is up, compare your answers with your teammates to see if you feel like you're on the right track. Yes. All right. So let's see how we did. Stay on your toes. So, now we're back as a whole group. Back as a whole group. So, part A, first tell me the vertex. Students 11 and 6. Student 11, what is the vertex? Student number 6, do you agree? The vertex is... And now tell me the minimum or maximum. Say minimum and then what its value is, and then say maximum and what its value is. Students 2 and 20. Student 2, what do you say?
Maximum 5.
Okay, student 20, do you agree? You agree? It's a maximum of 5? And maximum is 5. Very good. Part B. First tell me the vertex. I got student 3 and student 5. Student number 3, what is the vertex?
3, -1.
Student number 5, do you agree? The vertex is 3, -1. And what about the minimum or maximum? Student 13 and 19. Student 13. Student 19? Do you agree? It is a minimum of -1. Any concerns, any questions about this? Give me a thumbs up if you got both of them right. Well, that's pretty good. That's impressive. Good, put your thumbs down. No concerns of any kind? All right, so now let's go to one level higher. And this is not something you need to copy down. This is something we need to explore. But let's talk about domain and range, which we've talked about before, but is a little more complex when you talk about quadratics. The domain is the set of x's, the range is the set of y's. Unless we tell you something specific, you can assume that the domain is all real numbers. For the rest of today, we are going to be using all real numbers for the domain, which means that we use all of the x's, all of them. And that's what I was demonstrating before when I was indicating that they will go on and on and on forever. But the range doesn't. We can find the range by looking at its graph. And we actually have already figured it out, but we just have to learn how to put it into the right format. So if we look at this graph, we can see right here that this is showing us that the graph goes from this point up. So what part of the y-axis are we using for the graph? We are only using from here up. That's the range. The range is all the y values. Another way to say it would be, to say that I could erase everything down here because we don't need it for the graph, but I need everything from here up. So the lowest point for this graph is 1. But we're using everything from the 1 up, which means the y's have to be greater than or equal to 1. So the minimum and maximum values are really important because they tell us what the range is going to be. We just have to figure out what symbol goes in the middle. And that's what we're going to explore next. Any questions about that? Anything you need clarified? So let's take a look at this graph. You do not need to copy the graph for example 2. So we're asked to identify the domain and range, so we can just write D and R. And as I indicated already, the domain is going to be all real numbers unless it's indicated as something else. All real numbers. But the range we have to actually identify. We have to analyze. So we use the skills we just learned. We identify the vertex. From the vertex, we get the minimum or maximum, and that will help us with the range. So just by looking at this picture, you didn't have to copy it, but can someone tell us what the vertex is? Or a few people confirm what the vertex is? Essence, and then we'll go to Kyle. What did you think it was? Say it just a little bit. Okay, what did you think it was? What did she say? Then why would you confirm?
Because I didn't.
Oh, I thought you had. Okay, Raquel, what did you think it was? Okay, well, either way, you guys are close. We're talking about this point here. 1, 2, 3, 4, 5. So it's -5, -3. So it is -5, -3. Okay? Now, for this graph, are we going to have a maximum or a minimum? Maximum or minimum, Sam? The minimum. So this point here is the lowest point on the graph, and everything else is above it. It's a maximum. So this is the highest point in the graph. Well, it's a 50-50 shot. Which one is it? It's a maximum. Okay. So it's a maximum. So that tells us something. So all the points of the graph are below this point. We also already know how to find the maximum by just looking right there. So we already have almost everything we need to identify the range. The range is always going to be y. And we're going to use this number right here. We just have to figure out what number goes in between. I'm sorry, what symbol goes in between. And we just figured it out by saying that this is a maximum. So all the y's have to be what? Less than or equal to. So they all have to be less than or equal to -3. And that is how you express the range as an inequality. The y values must be less than or equal to -3. Any questions about that? Go ahead. It won't always be, but for today it will be. Very good. Any other questions? So let's just take a look at one other. And again, you do not have to copy the graph for this example. But we are going to identify the domain and the range. And the domain is all real numbers. So the question is, what's the range? We know it's going to be y. We know that there is going to be a symbol right here, and we know that there's going to be a number right here. So just find the pieces and put it all together. Go ahead. Raquel, what you got? Let's fill in the yellow highlight. What's the value that's going to go there? Very good. -4 is the minimum value of this. We can see it right here, -4. That's where that minimum point is. So now we just need to figure out what symbol goes in the green. What do you think? We got a bunch of people who know. Jamel, what do you think? Selena, what did you think? Very good. Greater than or equal to. All the y's must be greater than or equal to the -4. Outstanding. Any questions about that? Any concerns? So, checkpoint number 2. Don't copy anything except write CP2 and tell me the domain and range of this function. We're talking about a 1-minute activity. Good. Once you're done, compare your answers with your teammates to see if you guys agree.
Yes. Go back to your seat.
Okay. So, let's see how we did. All right, first I want the domain. The domain only, I got student 15 and 9. Student 15, what's the domain?
All real numbers.
Okay, student number 9, what's the domain?
Oh, it's fine. Why is this the three?
Oh
For me, all real numbers.
Okay, the range. I got student 6 and student 11. Student number 6, what is the range?
Why?
And student number 11, what is it? Y is less than or equal to 3. Very good. So excellent job. Give me a thumbs up if you got that right. 1, 2, 3, 4, 5, 6, 7, 8. Not counting hers. 10,
I got it
11, 12, 16. Okay, pretty good. Anyone have any comments or questions? Any concerns of any kind? Okay. Your homework is the same assignment, but make sure you've got it written down properly. And I want to remind you about what not to do for numbers 1 and 2. And that your test for chapter 7 is next Wednesday.